Now let's start out our discussion of machinery with the lathe, or engine lathe as some people refer to it. This name probably comes from the old days when electric motors weren't widely used. They usually had an engine placed outside the shop. Many were steam powered. These engines drove a drive shaft or a series of drive shafts that ran what's known as the headstock. And within the headstock is the spindle. Then, in order to drive the spindle, we have a motor mounted within the base with belts that rotate the spindle. On the opposite end from the headstock, we have the tailstock. The tailstock is used to support long pieces of material and is also used for holding tools. Now, the carriage and the tailstock need to be aligned and parallel to the spindle. This is accomplished by two rails along the top of the bed, actually part of the bed. These are known as ways. All machinery utilize ways to enable precise linear motion, and the alignment and condition of these ways to the compound is the tool post. I prefer the dovetail quick change style, which enables you to change tools and maintain each tool's position. There are several different styles that you may run across. This one is a 4-position turret type. And some of the older lathes will still have the single tool with a rocker plate that enables you to angle the tool up or down and change the height or center line. But each time you change a tool, you must that your tool contacts the workpiece just slightly below center line or right on center line. If the tool is above center line at all, it will flex down towards the center line under the pressure of the cut. This will cause the tool to pinch and dig in. It's also rubbing somewhat and will be likely to create what's known as chatter, from 16.1 thou or 16 1/10 to a half thou or 5/10. This determines the amount of travel that the tool moves for one revolution, or you can think of it as the thickness of the chip. Two axes of travel. The x-axis, or in and out with the cross slide, in or away from you is known as x minus, and out or towards you is x plus, and the z-axis, or right and left with the carriage, along the length of the bed. When you move towards the headstock left, this is referred to as z minus, and away from the headstock in favor of the carbide. I'm really going to stress this, especially those of you that are brand new to this, and even if you're familiar with machining, but you've never made your own tools. Your ability to manipulate and modify your tools will better equip you to meet the demands of a wider range of challenging setups. Well, there we have it, our finished tool. Now let's describe these cutting edges a little more specific, and this is just to give you an idea of what works. Like I said, there is no magic formula. Now generally, you'll want to rough in the relief first. This should be about 5 to 10 degrees from the front and side. And keep in mind, you are also creating a relief. It's not about tools and who has the most. It's about knowledge and application. It's about analyzing what needs to be done and understanding all the available methods to fulfill those needs. And more importantly, it's about knowing what to do when things go wrong. Not if, but when. Now it's time to get out there and be an active part in this world of machines. I'm Marshall Burr. Be safe.